Well, good afternoon. I'd like to welcome you to our talk here on design opportunities and energy efficiency. My name is Rae Lynn Fiscalini. I'm a local architect, landscape designer, and I'm also on the Sustainability Commission here in Benicia. And this is my design partner, David Subocz of William D.S. Studios of Santa Cruz. And David is a designer, an energy efficiency expert. He also does work with structural design and fabrication, and is also an expert in historic preservation. So we welcome you to our presentation. Oh, and I need the clicker too. Sorry.
So we were originally going to title this presentation, "The Role of Architects in a Carbon-Constrained Future," but that just seemed a little too esoteric, so we just settled on design opportunities. Oh, and yes, I am from the land of Santa Cruz, so I'm a foreigner in your country, so I hope you don't hold that against me.
Okay, it looks like our clicker is, oh, here we go. Okay, so first of all, I'm sure you're all very familiar with the 3 pillars of sustainability as you've visited different booths in the expo and probably from prior knowledge as well. In achieving sustainability, we want to integrate the social, economic, and environmental needs in a way that does not compromise future generations from providing the same in their time. And with regard to the built environment, you could say we've come a long way. This is a slide of an Italian hill town. My relatives came from Swiss Italian hill towns many, many moons ago. But this is an illustration showing the difference. It's a good contrast in that way back when people found it necessary to build with materials in the region, they built with an understanding of the climate and the seasons and the resources that were available, so they had to be very efficient and very focused on available materials and whatnot. Anyway.
And as an energy efficiency expert, what I really appreciate about this approach to, say, air conditioning, you open windows, and as far as heating, you use thermal mass, and in this case it's stone. So it's a very simple approach. It's absolutely reliable. It doesn't break down. You don't have to tune it. So I think that in many cases architecture is sort of looking back to the past for solutions to our current problems, and this is a great illustration of that.
Okay, thank you. And so back to the last slide. So we've come a long way, or have we? Here are some very extreme examples of how we've tried to outsmart nature, the limited number of hours of daylight we have, sort of stretching our needs out to the masses, so we each have our own individual homes on individual lots and communities linked through infrastructure. And I was wondering if any one of you here recognize this slide down here at the bottom. I'm pointing to it. Well, actually, this one right here. Oops, something happened. I think I just turned the screen off. Okay, here we go. Does anyone recognize this traffic jam? It's in China in 2010. There was a traffic jam that apparently extended over 9 days. I think you've got about 9 or 10 lanes in each direction. And even though this provides transportation from one community to the next, it's a representation of too much of a good thing, perhaps, and how it defeats the purpose if we have too much of one. Well, our solution is not the solution we had hoped for, let's put it that way. So as designers and architects, in looking to build sustainably for the long term, how do we go about doing this? And these are some of our attempts to do so through mandatory building codes. For example, the Title 24 California Energy Code has been in effect since the 70s, I believe, the late 70s. And in 2010, California incorporated the Green Building Code as a mandatory code for new construction. In voluntary efforts, many of you have probably heard of the LEED certification program, LEED standing for Leadership in Energy and Environmental Design, which focuses on certain aspects of the built environment, including energy efficiency, water efficiency, indoor air quality, sustainable sites, meaning siting buildings in the most beneficial manner with regard to the environment and transportation and whatnot, and also focuses on materials and resources. Go ahead.
So Rae Lynn is a LEED certified professional, and I'm a certified green building professional through Build It Green. And Build It Green, in contrast to LEED, Build It Green is more of a features-based approach. So it's looking for more passive sustainability features, things that don't wear out over time, that are incorporated into a building shell as a primary part of the structure. LEED has a tremendous focus on performance. So it's a performance-based standard for sustainable construction. And there are actually quite a few other competing programs, most that are coming out of Europe. One is the Passive House approach, and the other one is an approach called Living Building, which is if you really want to build for sustainability, Living Building is the highest standard that's been sort of handed out or developed in the last decade.
Okay, and I'd like to add one more, since I do landscape design for Bay Area residents. There's a group that is affiliated with stopwaste.org out of Berkeley that has published a Bay-friendly landscape and gardening guide, which is really the Bible for sustainable landscape practices that are applicable to the Bay, dealing with our microclimates, our soils, our just various and sundry limitations we have. And there's also a river-friendly landscape and gardening guide for upriver here, heading towards Sacramento. So this is an invaluable guide. It's available free online for downloading or PDF. Okay, next.
And one great thing about the internet is that there's access to so much information that is free, and oftentimes it's written specifically for a non-professional audience. So some of our clients are very keen on doing their own research ahead of time, so they ask us some very challenging questions, and they're really engaged in the process. And I think that's the biggest change in the design profession that's come about in the last 10 years. I've been involved in architecture for about 35 years, and it's only been the last 10 years with the access to so much information that clients have become far more engaged in the design of their projects than ever before. And I see that as a very positive development.
Okay, and let's see, the next. Do you want to talk about this?
Yes. So this is an example of one of the checklists from the LEED accreditation program. And one, I think, positive thing about the LEED approach is that it at least at surface, in its surface features, it's very approachable for most people. Most people understand a checklist. They can go through it, and they can think, well, yes, we can do this. Well, we can't do that. I don't know what this is, and there's no way we can do that. So it's one way of at least gauging at a very superficial level, at least how you might want to approach any sort of sustainability effort. There's a great deal of comfort that I think people find in checklists, And so LEED in that sense has a very strong program in that it does rely quite a lot on these checklists. And then the actual implementation of the items, that's more of a technical issue, and that's where the real challenge comes.
Yes, and the point with this slide, I think, is checklists are a great first step, but it's not necessarily the be-all and end-all answer. The ideal is really looking at taking a comprehensive assessment, whether it's a new project or an existing project where the focus may be on operations and maintenance, but using an integrated design process with contractors and consultants early on to come up with the best solutions for the long term, which includes the needs of the users, analyzing or just really understanding the business and manufacturing model of a particular client and the particulars of their site and environment. Are you going to say something else?
And as one example of a sort of integrated approach, we went into a local branch of a national bank, and they wanted some suggestions on their lighting system because they found that it wasn't really working very well for them. And so we walk into the space, and it's this large, voluminous area with windows flanking both sides of the space, and then outside of the window are parking lots. So one of the problems that they had was that in the afternoon they found it almost impossible to do paperwork or work on computers in the space. And I'm looking around, we're looking around, and we see that all the blinds have been dropped on the south side of the building, and they were these really heavy mesh blinds that blocked almost all of the natural daylight coming into this space. And what I realized is that there's a tremendous amount of glare that comes off of the windshields and the chrome on the cars that are parked just outside the building. And they say, well, yeah, we lowered the blinds because of the glare problem coming in. And so I'm watching them, and they're fidgeting around with their computer monitors, you know, whenever an SUV parks and the glare off the windshield comes blazing through the blinds, or even the blinds themselves have these hot flashes of light reflecting off of the cars. So we thought about it for a while, and we realized that really their solution for their lighting was about a 5-foot-high lattice work on the outside of the building with some nice flowering vines growing on it, so that the glare from the cars will be blocked from coming in to the space. They can keep the windows open during the day. They get all that natural daylight. It's a nice diffused natural light, which is perfect for doing paperwork. And so the solution was not a lighting solution. The solution was a landscaping solution. So that's how we approach projects from an integrated standpoint, is that we look at everything. We don't just consider well, we listen to the clients, at least for the first 5 minutes, and then we're sort of off figuring out what's best for them, and then they agree to pay for it, and everyone's happy.
Okay, very good, thank you. Okay, so in considering while we have checklists and an integrated approach, there are the most efficient ways or most effective ways to approach energy efficiency and resource efficiency, and I'll just go through these very quickly. We've heard earlier, especially with our keynote speaker from IDEO, David Haywood, the first night, it's all about understanding behavior, human behaviors, and getting behavioral changes, and Marie with Allied Waste knows all about that, and getting people to just change their mindset and conserve as much as possible up front. Really analyzing one's behaviors and how one uses resources is the best way to truncate waste and inefficiencies in the long run. Were you going to say something?
Yeah, and as an example of needing a new mindset, I went into this metal manufacturer's facility to consult with them on energy efficiency, and I was working with their facilities manager, and so I'm there specifically to talk with them about energy efficiency. And we were just talking, we weren't looking at any paperwork or anything like that. So he takes me over to their conference room. He walks in the door, and again, the first thing I noticed, the blinds are dropped, and they're very dark blinds. But what really surprised me is that we were just there to talk. There was, a little bit of light coming in through the blinds, and he immediately flips on both banks of lights in the conference room. His first reaction is to turn on all the lights, and so that's an example of a mindset or behavior that should be evaluated.
Okay, very good. And so, secondly, looking at new processes or ways of approaching projects, for example, using integrated design where you're using a very collaborative approach with consultants and clients and bringing experts in very early in the process to help set goals for a project. And third, using the new tools. We have so many capabilities now with energy modeling and different types of communication and collaboration tools. If you've checked out F3 over here, there's an amazing example of using technology to record as-built information and generate models that can be rapidly prototyped and incorporated into a design project for better decision making. And finally, with regard to new technologies, do you want to say a word about that?
Yes, I think that one of the earliest slides showing the Italian hill town, that's sort of an example of no technology. And then we have a few slides here that are slides from a winery where we did some energy efficiency consulting, and that's sort of the other end of it. That's this is pretty much a state-of-the-art winery, and it represents the new technology approach to creating the kinds of buildings that we need to live in or to work in. Oh, this ahead of time though. This is a project in Santa Cruz. The clients are a husband and wife. They were both artists. The wife was a musician. She taught piano, and the husband was a sculptor. So it was very challenging to come up with a design that would satisfy both of their needs, because they had very different needs. And this is their main living room. One of the things that they requested was the ability to hold piano recitals as part of her piano teaching, and so I needed to be able to have 20 adults, 30 to 40 kids in this living room. So rather than adding on to it, the decision was to make the staircase a lot wider than the code requires, and the kids can be piled up on the staircase. So I had all the kids in this very small footprint, and then the adults just would be sitting in chairs, and the space works beautifully for them. The staircase was a solution, and it was in lieu of adding on to the house.
Okay, all right, we'll jump ahead to the next one, right?
Okay, so this is the new technology. That big silver box on the right is called a chiller. This is at a winery, and basically what a chiller does is the internal mechanism is essentially the same as your refrigerator at home. The refrigerator makes cold air and then pumps it into a box, and that's how you keep your food cold. What a chiller does is essentially the same thing, except it's cooling liquid, and then that liquid is circulated through pipes, and you can see the two pipes coming out of the chiller. One is the outgoing and the other is the ingoing, and behind that are two large insulated water tanks, and those are used to harvest the waste heat that comes out of the chiller, and it makes hot water, and then they use that hot water to wash down their big plastic grate bins and just to basically clean up. And then there's a bunch of some mechanical apparatus there that I didn't spend too much time focusing on. Their big issue was the chiller and how much electricity that was using. So these are the two pipes coming out of the chiller, going up the side of the building. And this is where I usually ask the audience, what's wrong with this picture? Right. There's actually two things wrong with this picture. No, that's not it. But yeah, that's probably another issue. Well, one of the pipes is the outgoing, and yes, ideally these pipes should be insulated because this is the most important part right out of the machinery that needs to be insulated. But the other thing is that the return line is covered with ice. So the liquid going out, it's difficult to see in this photograph, but the outgoing pipe you would expect to be covered with ice because the liquid coming out at 25 degrees. But the water coming back should be warmer. And in this case, the line coming back is also frozen. So that's something that I don't need to monitor it with a lot of expensive equipment. I can tell by looking at it that there's something not quite right with this system. So this is the inside of the chiller. I just wanted to show it to you mostly so that you can get a sense of how complicated a piece of machinery this is. And this is another picture of it. The part you're looking at right now is very, very similar to what you have in your refrigerator. This is just a bigger version. This device is called an evaporator. This is in the winery's barrel room. And what they do in a barrel room is they condition it down and humidify it so that it basically mimics the temperature inside of a cave, which is, of course, how wine used to be made. And it is today, it's kind of vogue to have a wine cave. And this is a man-made wine cave. It's an insulated box, and the cold liquid circulates through this device, the evaporator, and then the evaporator blows cold air into the space, just like your refrigerator, and that's how they keep this space conditioned for the fermentation of the wine. But this is looking up at the evaporator. This is the back side of the evaporator, and that's one of their taller, I think it's a 3,000 gallon French oak barrel. And you can also see ice has formed on the back side of the evaporator, both the incoming and the outgoing. So again, that tells me that there's some issues with the size of the system, the velocity of the coolant going through the pipes. There's all kinds of potential issues. One thing I noticed is that since the temperature in the barrel room's kept at about 50 degrees, that ice only forms as the liquid circulates through. As soon as it shuts off, the ice eventually melts, and it drips onto their 3,000 gallon French oak barrel. So the low-tech solution was to put a plastic tarp over the barrel because they didn't want the water dripping onto the top of their barrel. So that's a case where the low-tech approach is preferred. Now this goes back to the Italian village that we saw early on. This is a state-of-the-art winery. They have this beautiful Italian-designed hydraulic grape press that they use for pressing the grapes, getting the juice out in order to make their wine. Well, that machine isn't as efficient as you would hope, and so what they do is they take the grapes that come out of the hydraulic press, they put them in this large plastic bin, they fill up these mesh bags, and then they stomp them with their feet to get the rest of the juice out. So sometimes the old ways are still the best ways, and I think that that's an important lesson as we move forward in sustainable design, that we keep in mind that sometimes the old and easy ways are the best ways to move forward.
Okay, here's our bottom line. So the bottom line here, and you can read this as well, is when we balance the economic, environmental, human factors, which we understand as the three pillars of sustainability, it's essential to designing the most efficient, productive, and sustainable solutions for the long term. And we're looking at clean tech with regard to building science as the design and implementation of what the appropriate strategies for the long term, whether it be they high tech, low tech, or no tech. So thank you for coming and sitting in today. Are there any questions?